All right, here we're reviewing ratios and proportions and just the idea of how to solve these things, how to set them up, that kind of stuff. So let's talk about a proportion. Hopefully you remember that a ratio is just a fraction. It's just comparison of two numbers by division. But a proportion is when we have ratios that are equal to one another, okay? So two fractions that are equal to each other. And we solve those by cross-multiplying. All right, so if we have two fractions that are equal to each other, we cross multiply. We take the numerator of the one times the denominator of the other, and then we do the same thing with the remaining numerator and denominator, and then we just set those values equal to one another, okay? So top times the bottom, the other top times the bottom, set them equal. That's cross multiplication, and then we solve what's left. All right, we're essentially changing this from something that has fractions to kind of a regular equation that we're used to solving. All right, so again, proportions, two fractions set equal to each other, we cross multiply. Here, this guy times this guy, A times D, this guy times this guy, B times C, and then we set those equal to one another and then solve. All right. For example, if I look at something like these guys, all right, again, I'm going to cross multiply, so I just take the top times the bottom, the other top times the bottom, and I set them equal to each other. So if I look at something like this one, I do something like 5 times the x. Notice they're across from one another. That's why it's called cross multiplication. I just multiply those. 5 times x is a 5x. And then I take the other values, the other top and bottom, the other numerator and denominator. The 6 times the 4, that's a 24. And I think most students remember to do the 5x and the 24. They remember to multiply across diagonally. But what they forget to do is what to do with those values. And hopefully you just keep reminding yourself you set them equal to one another, okay? When we cross multiply, we set them equal to each other. I've seen students do all kinds of silly things like set them up as fractions, that kind of stuff, all right? We set them equal to each other, all right? Top times the bottom, set them equal, all right? And now I can solve this thing. This is just a one-step equation. I have 5 times x equals 24. To undo multiplication, I'm going to do division. So I'm going to divide each side by 5. To undo multiplying by 5, I divide by 5. The multiplication and division cancel each other out, so I'm left with an x. Over here, just plug this into your calculator. You can do it as a decimal, that's fine. It's going to give me a 4.8. Okay, that's it. All right, and you could even check these to see if the fractions are the same or see if the decimal approximations of the fractions are the same, but that's it. Okay, this one, if I cross multiply, once again, I'm going to do the m times the 3. That's a 3m. I'm also going to do the 4 times the 6. That's a 24. I happen to get 24 again. And now I set these equal to one another. And now I solve. Okay? So if I have 3m equals 24, to solve this, I'm going to divide each side by 3. Again, the times 3 and divided by 3 cancel out. So I get m equals, and it looks like an 8 this time. Okay? If I look at the next one's a little bit trickier as we work through this thing. But once again, if I just take y times the 9, that's a 9y. Let me write it down. And then the other part of this thing, the y plus 4 times the 3. All right? And in order to do y plus 4 times 3, let me take it off to the side. If I do 3 times y plus 4, that's times that entire thing. Make sure you use parentheses there. Okay? And so it's times that entire thing. You have to use your distributive property to actually do this multiplication. So let me write that down here. So equals, that's a 3y plus 12. Okay? Some students will try to do that in your head. I sometimes recommend against that. If you can do that in your head, use that distributive property, that's okay. But take it off to the side. It's that thing times that entire thing. Use parentheses, use your distributive property, and then write it down. Okay? And now from here, if I want to solve this thing, I have to simplify and then solve. I simplify by getting my y's on the same side. I've got y's on two different sides of the equal sign. So I need to get rid of one of those. I'm going to get rid of the 3y by subtracting 3y from each side. Once again, these cancel. So over here, I get a 6y. Over here, that cancels. I get a 12. Now I can finish solving this thing. To undo multiplying by 6, I divide each side by 6. Okay? So y equals a 2. Okay? Taking a look at some of these, this is really where we use proportions in real life, okay? Is when we're trying to adjust things. Recipes are a good example. So a recipe will feed 4 people, all right? and it uses 3 cups of flour. How many cups of flour are needed if I want to serve 22 people? So I have to change this recipe. I have to multiply the recipe, all right? And if it's kind of something oddball like this, if it was 4 people to 20 people, well, that's just times 5, so then I can multiply the recipe by 5. But when it's something like this, I have to set it up as a proportion, okay? When you do this, the thing that's important is that you set each fraction up in the same way, all right? It doesn't matter the way I compare the 4 people to the 3 cups, all right? I could do 4 over the 3, or I could do 3 over 2. What matters is that I set up the second fraction the same way. So this one, I'm just going to write them down the way they're written. So let's see, it was 4 people goes with 3 cups, all right? So I just did 4 over 3, all right? And that's my first ratio. It's 4 people goes with 3 cups. The second ratio, then, I just have to make sure it matches, all right? So notice my first fraction was people over cups, so my second fraction also has to be people over cups. And it says that I want 22 people, but the number of cups is the thing I don't know, and the thing I don't know just becomes my variable, okay? So again, the key here is to set up each fraction the same. The first one was people over cups. The second one also has to be people over cups, okay? And now I can cross multiply. Once again, I do the 4 times the x is a 4x. I do the 22 times the 3 is a 66. And I set those equal to one another because that's how cross multiplication works. Okay? And now, of course, to solve this thing, I'm going to divide each side by the 4. The times 4 and divided by 4 cancel, so I'm left with x. And over here, that gives me 16.5. Okay? So 16.5, or let's write it as a mixed number, 16.5 cups, and that was of flour. And here's the thing, obviously that's not the only thing in the recipe. We probably have a bunch more of ingredients, but we find the measurements for all of those ingredients the same way, okay? And so what we do is we adjust this recipe, we find all the new values for the ingredients, and now we can mix this thing up and get a recipe that'll feed 22 people instead of the 4, okay? If I look at something like this guy, it says a 30-minute show takes 20 minutes to download. How long will a 2-hour movie take to download? And so regardless of, how we're looking at this in terms of, speeds vary and stuff like that, I get that, but let's assume that it's a constant speed for download. But the thing that you should notice right away is one of them was in terms of 30 minutes, and the other one was in terms of 2 hours, all right? And so as we kind of set these fractions up and try to make them the same, we also have to make sure the units are the same. So right away, before I even start this, let's look at this 2 hours. Instead of saying 2 hours, let's say 120 minutes, okay? And see, that will be helpful to us because now this was in minutes, and now this is also in minutes. And I need that because as I go to set up this fraction, again, setting up this fraction, I have to have each fraction set up the same way, so those units have to be the same. So if I look at like the first one, it was a 30-minute show. That's the actual length of the show over 20 minutes. And that's the other thing that's tricky. These are both minutes. But the first one, the top one, the 30, is how long the show is. And the 20 is how long the download is. Okay? So it's the actual length over the download. And so as I go to do this second fraction, I have to do the same thing. I have to do the actual length over the download. And so when we look at this, the 120 is how long the movie actually is. And I want to know how long it's going to take to download, so that's my x. Okay? And so again, it's all about setting these up so that everything is in the same spot, everything's in the same position, so that each fraction is set up the same way. Okay? 30-minute show, 20-minute download, 120-minute show, I don't know the download, okay? But I set each fraction up the same way. I make sure all the units match, and now I can cross multiply. Here, 30 times the x is a 30x equals 120 times the 20. It's going to be a 2,400. And now to solve this thing, I'm going to divide each side. So here, I divide each side by the 30. And again, use your calculator to help you out with some of this stuff. Now let's see, that's going to be 80. And that's minutes. That's going to be 80 minutes to download. And, always make sure it makes sense in context as well. when you looked at the 30-minute show, the download took less time than the actual length of the show. And so as I look at this 80 minutes, does that make sense for a movie that's 120 minutes? Well, yeah, it should take a little bit less to download than it would be to actually watch the movie. Okay? If I look at this guy, it says an architect draws plans for a house. On the drawing, every quarter of an inch, 0.25 inches represents 1 foot. Write the ratio. And so as I look at this thing, there's lots of ways that I can write this ratio. I could literally write it using the values that I have and say, hey, the 0.25 inches over 1 foot. Okay, that would be an acceptable way to write the ratio. Okay, we could also change it a little bit and actually plug this into our calculator. If you actually plug this into your calculator, of course, it's going to give you the 0.25. But the only thing that's different is we rewrite the units as 0.25, and then we say inches per foot. Okay, so we could write it as a single value and then kind of express it this way. But we could also do this kind of without decimals. If we kind of think about it this way, that's like a 1/4, all right? And so if I looked at it this way, if I had 1/4 divided by 1, or I could go the other way, sorry. 1 foot divided by, we'll just keep it as a decimal since we've been doing it that way, okay? You could write the ratio like this. 1 foot goes to that many inches. Or you could write it as 4 feet per inch, okay? If you actually divided that, 1 divided by the 0.25, all right? And I point that out because some of these ratios are probably easier to use than others, okay? Like these two ratios are pretty much the same thing, all right? This ratio is right in line with that, but this ratio right here, you could express that as 4 feet over 1 inch is kind of the same thing as 4 feet per inches, all right? This might be a nicer ratio to use as we're setting up these fractions and multiplying so that we don't have to deal with the decimals, okay? So there's lots of ways to express this ratio. I just want you to be aware of that, okay? Now, using that ratio, it says if one of the rooms is supposed to be 12 feet by 15 feet, how big should it be on the drawing? And so I just have to convert each of these. And so I have to do one of these at a time. Maybe I'll start with something like the 12, okay? And so I could take any one of the ratios that I did up here. So like if I took the first one, it would be 0.25, and that's inches over 1 foot. And notice I didn't write the units this time, but I understand that the top is the inches and the bottom is the feet, okay? So then when I want to do the 12 feet, well, that has to go in the bottom. See, because when I look at that first ratio, it's inches on the drawing versus feet in real life. So my second fraction has to be inches on the drawing, which I don't know, over feet in real life. And now I could cross multiply. And notice I have to do one of these at a time. I'm doing the 12 first. Next I'll do the 15. But now I cross multiply. X times 1 is an X. And then using my calculator, 0.25 times the 12 is a 3. And that's 3 inches. 3 inches on the drawing, okay? If I do the next one, I'm going to use a different ratio this time. Now I'll use the ratio that's in this little thought bubble here. It's the same thing. If you want to use the 0.25 over 1, if you don't mind the decimal, that's fine. Use the same one each time, okay? But if you were doing this maybe without a calculator or something like that, this ratio might be a little bit nicer, the 4 feet over the 1 inch. The other thing is I have to make sure I set this up the same way. So now that I'm using this ratio, that was 4 actual feet goes to 1 inch on the drawing. So if I'm looking at 15 feet, well, that would be 15 feet in real life is how many inches on the drawing. And so make sure you set up each fraction the same way. Like when I did the 12 feet, I did inches over feet, so the next one had to be inches over feet. This time I did feet over inches, so I have to do feet over inches for the second fraction. Cross multiply. So here we go. 4 times the x is a 4x. 1 times the 15 is a 15. And now I can solve this thing. I'm going to divide each side by the 4. So those cancel. So find out that x equals, let's see, that's going to be 3.75. And again, that is inches. Okay? And so as I draw this thing, if the architect is drawing this thing, on the actual drawing, on the blueprint, he's going to make it 3 inches by 3.75 inches. Okay? If I look at this guy, it says one of the rooms on the drawing is 3 inches and the other one is 3.5 inches. How big will this room be? Well, we already know one of those measurements, but let's pretend that we don't, because we had a 3-inch measurement and that went with 12 feet, so it's going to be 12 feet. But let's set it up in terms of the ratio. Maybe I use this other ratio of the 0.25 over the 1. Maybe we liked that better. Okay? And so once again, I say, okay, that's inches over feet, inches on the drawing to feet in real life. So 3 inches on the drawing over how many inches in real life? And I cross multiply. Here, this guy times this guy, that is a 0.25x equals 3 times the 1, that's a 3. And now I have to divide each side, and this is where my calculator will be pretty helpful when I'm dividing by a decimal here. So I find out that x equals 12, and that's 12 feet. Okay? I could use the same ratio. I'll use the same one if we don't mind using the decimal this time instead of switching it. All right? But this time I want 3.5 inches goes with how many feet in real life. Okay? But again, inches over feet equals inches over feet, and now I cross multiply. This guy times this guy, that's a 0.25x. Right here, 3.5 times the 1 is a 3.5. The nice thing about this ratio is the fact that there's a 1 in there makes things a little easier. Now I divide each side by the 0.25. So again, over here these cancel, so I'm left with the x. Over here, once again, that's a job for my calculator. And it looks like I get a 14. So 14 feet. Okay? So in reality, this room's going to be 12 feet by 14 feet. Okay? And keep in mind, once again, I used that ratio of 0.25 over the 1. We could have just as easily used this other ratio of 4 over 1. Okay? So if you like that ratio better, you could easily use that ratio of 4 over 1. Okay?